Terrific. Okay, so we're going to be recording this. And while we get started, I would encourage everybody to drop some information in the chat, introducing yourself. Let us know your name, what company or organization you're from, where you're located, and if you have a fun geophone related fact you'd like to share with us, please drop that in the chat. I can't promise that I have any fun geophone related facts, but I guess a fun seismic related fact was that when I was in graduate school, I studied oceanography. So we did quite a lot of work with seismic sensing, and that was kind of a lifetime ago, but definitely something that we utilized quite extensively back then. So we are here to talk about the Geothermal Geophone Prize, which is a prize competition offered by the Department of Energy's American-Made Challenges or competition. And one quick question, those of you who at least have cameras on, just let me know by a show of hands or drop in the chat. Let me know if this is your first time attending an event on this particular prize competition. I'd be really curious to know if we're speaking to any first-time audiences. So raise your hand or feel free to drop in the chat. Okay, so we have at least three new people. So terrific. Well, you still have plenty of time because the prize challenge is due on September 29th, and it's a fairly short application, as we'll explain in just a moment. But we're glad that we caught you here, and we are going to share a few links to resources that have already been pulled together on this particular prize challenge, some webinars that you can review to look for more information. But today we're also just here to kind of quickly review the goals of the prize and then spend a lot of time going over your questions, as well as providing some opportunities for you to introduce yourselves to fellow applicants and discover if there are any potential teaming opportunities. And I'll talk a little bit more about that in just a moment. So if you could go to the next slide. Great, so I just want to quickly review what you need to submit, when you need to submit it, and where you need to submit it. So I mentioned the deadline for applying for this prize is going to be September 29th. And if you see this yellow link at the bottom of the screen, you will be submitting the application on a platform called HeroX, which is what the Department of Energy uses to manage all of its American-Made Challenges prize competitions. So if you visit that link, you will find the rules, a whole variety of resources, a great forum where you can discover answers to some of your questions or post questions, discover potential partners. You'll also find a link to the American-Made Network, which is a great resource where you can connect with potential power connectors and connectors in the American-Made Network. These are nonprofit organizations, national laboratories, testing facilities, universities, etc., who can offer various forms of support for you, usually at no cost. So look for some of these resources all via the American-Made Challenges website and the HeroX platform. So quickly, what do you need to submit on September 29th to apply for this prize? You need to submit a 90-second video. This will be made public. It will not be scored as part of your prize competition, but the goal is to inform the public and other people interested in this prize about what you are planning to do. This does not have to be something that's incredibly professionally filmed. You can make this on an iPhone. You can make this using PowerPoint animations. Definitely feel free to reach out to our team if you have questions about low budget, easy hacks for making videos, because we've done quite a few of those things ourselves. But basically, you want to tell a story about what it is that you're proposing to accomplish. You also need to provide your cover page. And if you look at the HeroX platform, you'll find more guidance on what is required there, as well as a single PowerPoint slide summarizing your project. Additionally, there's a technical assistance request that you need to complete. And those four documents are all either geared for the public, or in the case of the technical assistance, it's geared for the public, but also potential connectors and others that might help support your team. These are not scored. The two components that are in some respects scored. So definitely the technical narrative about your proposal. This is describing what innovation you're proposing, what's your plan for executing that, and what is your team, what kind of capabilities you bring. That's the main meat of your application. And that's going to be, you know, a fairly brief document, but that's where you really want to get into the meat of what you're proposing to do. And then finally, these are optional, but you can provide letters of commitment or support. These can be useful if you are planning to work with other partners who bring certain testing facilities or fabrication resources or skill sets to the team that your core applicants team does not possess, but are, you know, interested in working with you. So one thing I just want to note is, you know, I've talked a little bit about teaming. This particular prize, and I actually wasn't planning to go through this, but since we have a few new people on the line, Andy, can you just quickly flip to the slide near the end that has the table of all the requirements? So I'm not going to go through all of this. You know, I kind of have these slides in here as background in case we need to go back, you know, through the prize to review with anyone who might be new. But I just wanted to show this performance goals table briefly. So this is in the rules document, and this is a table with sort of the acceptable and then ideal or stretch target goals for this particular prize competition. And you know, essentially, these are some of the technological challenges in geothermal geophone sensing that this prize competition is hoping to address. And so as you can see, you know, this is an ambitious range of performance goals, and it might be difficult for one single company or one single researcher to meet these goals on their own. So we definitely encourage you to think creatively about teaming to, you know, speak with other people that are on the call today or who attended our previous webinar and teaming event, or who you find using the teams that have signed up using the American-made Challenges Hero X forum. We also have a brief 3-question teaming form where you can talk a little bit about what kinds of capabilities you have and what kinds of capabilities you might be seeking. So, you know, definitely think creatively about skill sets that you can leverage to bring to the table here. So, Andy, go back to the CEBN, CEBN resources. So I just want to also talk a little bit about some resources that our organization has to support your team in applying for this prize. So briefly, who is the CEBN? We are the Clean Energy Business Network, and we are the small business voice for the clean energy economy. We are a nationwide nonprofit organization that supports small and mid-sized companies in the clean energy industry through policy engagement, market and technology education, and business development assistance. And we have a network of a little over 6,000 small businesses in our network, representing a very broad spectrum of technologies. And we also are a power connector with a subcontract with NREL to help support the American-made challenges, and we are working to help support applicants on this prize. So just to alert you about some of the resources we have available, we have a completely free US clean tech funding database. And we'll share these slides so you know you'll have all of these links, and my colleagues can also are actually currently dropping them in the chat right now. But you can navigate this to look for other geothermal related or other types of funding opportunities of interest to you. We also are offering one-on-one office hours to anyone who's interested in applying for this prize, and you can book that via our Calendly booking link and set up a time to speak with our team, talk a little bit about what you're interested in, any needs you have. We can also help review your application and give you any feedback. You know, we'll provide more of a lay level feedback. We have a few of the technical experts on the line today, but we have worked on a variety of these challenges and can give you a good sense of how to structure your application for success. I mentioned earlier our teaming form. That is one of many ways that I mentioned that you can find other potential co-applicants on the prize, or those that can work to help support some of the technical capabilities that you need. And then finally, feel free to just email us at cebn@cebn.org to ask any questions that you might have. So, you know, I mentioned earlier, we are a power connector, but there are so many connectors and other types of resources available if you navigate to that HeroX webpage. So definitely check those out. Feel free to email us with any questions. So we're going to stop slide sharing for a moment now. I do have other slides regarding the prize specifically if anyone wants to go through that, but assuming that many of you have already looked at some of the rules and are here to get your questions answered, we want to definitely spend the most time on that. So we're going to turn it over to all of you in just a moment, but before we do that, I wanted to introduce a few wonderful experts that we have on the call today that can help with addressing technical questions you may have. So first, I'd like to introduce Lisa Trope from the National Renewable Energy Laboratory, and she is one of the administrators on this prize. So Lisa, did you want to say anything to the group?
Sure. Hi, everyone. Lisa here. I live in Lakewood, Colorado, which is just outside Denver, and I am the prize administrator for this prize. So essentially, I work with teams to support them throughout the process. I work with CBN connectors, GTO, LVNL, and so on this prize, and I work with teams directly and also work on all the logistics for the prize, just making sure everything is up and running smoothly. I'm happy to answer any questions and just be here to support. So I'm kind of the go-to person if you have questions about the rules document or applying and so on. So
great. Well, thank you, Lisa, for joining. And one thing I'll just say for those who are kind of new to the American Aid Challenges program and may be used to other types of federal funding, it is a very accessible type of funding opportunity. So, you know, you have met a person, Lisa, who is the prize administrator. She's offered that you can ask her questions. There's not a black box. There's actual humans on the other side of this equation, and you can feel free to reach out to them. We are also excited to have two experts from Lawrence Berkeley National Laboratory, Michelle Robertson and Ernie Major, who are both well-versed in the seismic sensing for geothermal systems. And Michelle, I think in particular, was one of the contributors to designing this prize. So they've joined us today to be a resource on any technical questions you have. So Michelle and Ernie, is there anything you'd like to say to the group?
Yes, other than is mostly Ernie and I putting those specs together with some input from a lot of experts, not just us. But I'm been at Berkeley Lab since 2011 and been working with Ernie all that time. So my background is in seismic monitoring, borehole monitoring, fiber systems, high temperature systems, as far as we can go, and mostly for geothermal, but also with other projects as well.
Yeah, I've been at LBL since I was little, and for a long time.
Did you go to preschool there, Ernie?
Yes. And so working in the same areas as Michelle has in terms of, you know, seismic monitoring and instrumentation development and improvement and things like this. And this is a really good opportunity. We're looking forward to being able to have somebody develop those according to those specs. And intellectual property. What happens to the intellectual property that's developed during this? Does it stay?
The government, yeah, so any intellectual property that teams create under this prize is owned by them. GTO or otherwise doesn't have any, doesn't get access to their intellectual property through this prize. With that being said, you know, when teams win the prize, they will be having the opportunity to work with the National Laboratory. And at times there are contracts put in place with those laboratories to be able to do that work, to continue to work on their prototype. But any contract that's in place, any language around IP would be in that contract, and teams would be able to review it before deciding on moving forward.
So the vouchers, will that come from DOE directly, or will that come through a lab?
So the vouchers for this prize, teams can either work with a lab or they can work with a private entity. So if a team wants to work with a lab outside of a national laboratory, they're welcome to.
Okay.
Essentially what teams will do is we'll have them, so actually there was a small update on that slide around the technical assistance request. That will actually just be a one-page voucher slide where teams will be sent a capabilities menu over the next week or so. where they will essentially be able to look at which national labs are interested in collaborating on this prize, and then also the step-by-step of how they could also work with a private facility. And they'll submit that voucher slide with their submission package. And then from there, if they're a winning team, we work on a contract and so on, either with that national lab or with the private entity.
Yeah, because they will have their own intellectual property, some of these companies, that they're going to bring to the table, you know, and they want to modify it for our needs. And so a lot of those questions, and depending on who owns that existing, you know, sometimes things can get complicated. So.
Right, but it sounds like at least just to kind of clarify, you know, at the point of application, the information that's submitted. So there are the private technical, you know, narrative document that any intellectual property in there, it belongs to the company, and then it's sort of up to the winners to decide should they want to enter into CRADAs or other types of agreements with the private entity or with the national lab. Then the breakdown of IP will be negotiated at that point.
So they can use those vouchers for anybody. It doesn't have to be a national lab then. Is that right?
Yes, for this prize.
For that price, okay. I didn't know that.
For yeah. It's not always the case, but yes, for this prize.
And finally, in terms of the introductions, I wanted to just also flag a few of our CEBN team members that are on the call right now. I've got Andy Barnes, who is our Director of Policy and Communications, and Ali and Judge and Annabelle Swift, who are our associates. And so the four of us are all available to answer your questions, you know, help connect you to other teams that we think might be a good fit for you, and, you know, otherwise just help to support you through this prize. I mentioned also we're happy to take a look at your materials. So with that, I'd like to now take some time. I know we started a little bit with some common questions that Ernie raised, but just take this time to answer your questions. And then when we run out of questions, I would love to try to turn to everyone on the call to just introduce yourselves. And oh, I think we have Zach, it looks like Zach Frone is here as well. Did you want to say hi quickly to the group?
Yeah, good afternoon, everyone. Yeah, I'm Zach Frone with the Geothermal Technologies office. So I've kind of been running the prize from GTO side here, and happy to be working with all of the various people on our team here, and excited to have you all see that you're interested, and can't wait to see what you all come up with.
Great, thank you so much, Zach. So with that, let's turn to answering any questions you may have, and then we can go around and do some introductions and learn a little bit more about the type of work that you're doing. So feel free to unmute yourself and ask your question, or if you're feeling shy, you can drop it in the chat and then we can read it out loud. Okay, it seems like we don't have any burning questions yet, although some might occur to you as we go through the introductions. So why don't we go through, and I'm just gonna call on folks as I see you on the screen. And if you're able to unmute and introduce yourself, that would be great. You know, if you are not in a good place to unmute yourself, then no pressure whatsoever. But we'd love to hear, I see, thank you to everyone who's been dropping information in the chat, and I see actually some fun ones. I actually have a question about one of the things I see in the chat, but I'm gonna ask you each to, again, just introduce yourself, let us know what company or organization you're from, and tell us a little bit more about your specific interests in the prize. You know, or what are you thinking about in terms of your potential participation as a prize applicant? So I think the first person I'm seeing in my list is Harold Snyder.
Good afternoon. I am an applied physicist and scientist. About 50 years, over 50 years of experience in designing downhole tools, including seismic tools and the like. One of the previous on the previous team meeting, for example, I showed a lot of our work is in hybrids and multi-chip modules. So if you can see that, probably not very well, but that is an example of a hybrid that I designed for service company. It exhibits about 147 dB of signal to noise for a downhole 3C seismic system. So lots of experience. We're contemplating entering one of two designs that we have, both of which meet the specifications that are being looked for. And we're still trying to decide at this point which one to enter. And we may open the other one up as a co-teaming effort with somebody else if perhaps they want to enter the contest, but don't have a solid design or a design that will meet the requirements. We may open one of those designs up to somebody else for hello there, for use by somebody else, and we would team with them. So we're open to that as well.
Okay, great. And is there anything else you'd like to state with respect to those kind of teaming opportunities that you described?
As to, we're still discussing that internally.
Okay.
So it's a lot will depend on which of the two designs we actually put forward for the contest, because we don't have at this point we don't feel like we have enough time to adequately enter both designs before the deadline. So we'll choose one, and if somebody else is interested, we may team with them to do a co-entry for the second one. So that's still something we're discussing internally.
Great. Well, thank you for that background.
Can I ask a question, Harold?
Of course.
Sure.
So that device that you showed us is the total package of the sensor and the electronics?
No, the actual sensors for that are accelerometers, high temperature accelerometers that are designed for use at temperatures up to 225, limited service to 250. What the hybrid that you were just looking at is a triple A to D converter system, and there's it has an extremely low noise reference and an extremely low phase noise clock. These are delta sigma converters, and anybody that's familiar with delta sigma converters, you know that you have to have an extremely low phase noise clock in order to run that, or your signal to noise suffers greatly.
What is that used for now?
It's still that particular work is still being used for downhole seismic.
Okay. Okay.
So if you are you asking as to which company that was actually designed for?
Well, you don't have to tell me.
I can tell you it was done for Schlumberger.
Okay. All right. So Schlumberger and their Schlumberger system. Okay.
Yes.
So if somebody came to you with a different sensor, and
Yes.
a different, let's say, front end, then you'd be willing to team with them.
I would be willing to team with them. And so at this point, we expect to submit the design for a complete system, complete tool. And it would probably be using a variation of this, a slightly improved variation of this for sensor. At this point, we're leaning toward an accelerometer sensor for that tool. We've had the best luck with those for downhole seismic, And so it would be a 3C system, would meet the specifications for this prize. And so that's the one we're leaning for. The other one is an improved design for a geophone, which doesn't have the limitations of the current geophones. So it would have a frequency bandwidth of about 0.001 up to about 5 kilohertz or so.
Yeah. Okay, good.
Great. Well, I see the next person that I have in my list is John Holmes.
I'm Jim Holmes with Ozark Integrated Circuits. I'm the chief scientist here. We're located in Fayetteville, Arkansas. So we get a lot of questions from our state reps because the Ozarks have quite a bit of geothermal activity. We got, I don't know if you've ever heard of Hot Springs, Arkansas, but there's quite a bit of heat up there, and it's been a point of interest for quite a long time. My questions are there along with accelerometry and a geophone and the seismic measurements, is there a need, and I suppose this question's for Ernest, is there a need for correlating other measurements as well, like temperature, chemistry, conductivity, things like that?
Instrumentation for it, or just data processing?
Just correlating that with seismic data, like the time, you know, and some sort of seismic event is measured. You want to know the temperature of the sensor at that moment. Is that a critical piece?
Well, it's mainly focused on the sensor itself. It's gathering seismic data.
Okay.
At those temperatures and pressures. And then
Yeah, I'm sorry. Go ahead.
Go ahead, Harold.
I was just going to answer part of his question. There is that there is a need for the co-measurement of temperature. Quite often, when you do a fracture, the fluid that you're fracturing with is almost always cooler than the formation temperature. And so one of the things that you look for is the temperature profile in the wellbore as the fracture pressure starts to release. After you quit pumping your proppant and your fluid into the formation, then that pressure will slowly decrease. And so one of the things that you track quite often is the temperature. And quite often in these surveys, you'll see, in addition to the measurements of seismic measurements for that in the wellbore, you're also looking at temperature changes as well. So to answer your question, yes, co-measurement of other parameters is very typical.
Yeah, well, there's no doubt about that. But what we're interested in here is looking at the ground motion associated with the fracturing itself, and from very small ground motions to very big ground motions over a wide frequency range.
Yeah, it's that dynamic range that's very good. But there's the prize need, and then there's industry need. So for the prize need, no, this is not necessary.
No doubt about it, Harold. They need those things too.
Yeah. So in the context of the industry, then if you have an instrument that's in the ground, and while you're there, you're collecting things like temperature, pressure, pH,
conductivity,
density.
Yeah.
You never have too much data.
Right.
With respect to the seismic events, is there a need for zero data suppression where when you're looking at transmitting data to the surface, where you want to consider an undisturbed sensor. You're not transmitting reams and reams of zero data. Is that ever a system level aspect that needs to be considered?
Yeah, that could be considered. Yeah, but I mean, you want to get as low noise as possible. You want to get out that noise. You know that you're always there somewhere, seismic noise, and you have a means to really suppress the seismic noise to get better data. Then yeah.
Okay. I guess I have a question on exactly what it is that you're looking for as far as zeroing out. Are you talking about active noise cancellation in the hole, or are you talking about actual transmission of the data from downhole to the surface? Which so I've dealt with both problems, and so I'm looking to get clarification exactly what it is you're asking about.
I'm really asking from the perspective of data collection. So if I'm looking at a system where I've got accelerometers with a 1 kilohertz bandwidth and a geophone with a 300 kilohertz bandwidth, I've got 2 channels, and the geophone channel is effectively quiet. Right? There's nothing happening. There are periods of quiet, right? And now if I'm transmitting analog information uphole, then my data conversion is happening at the surface, and my data aggregation and my correlation of the time base is happening at the surface, right? That's one thing. If I'm doing data conversion in situ to an extreme environment, and I'm collecting data and I've got quiet data and I'm transmitting packets of information to the surface, I might have dead time that it would be, I could save transmission bandwidth or packet data density by sending a 0 instead of thousands of zeros. Right, it's a common instrumentation technique in other physical environments, like the deep underground neutrino experiment. They have a big spec on these aggregated sensors that are looking for something in space, and they're getting tremendous amounts of zero data. So they have to put that intelligence as far forward into the sensor space as they can in order to filter out data. Is that a problem in general in the operation space of some of these shallow geothermal formations, or am I overthinking it?
I'll speak first, Ernie, and then I'll keep it short. Is that in general, I would think that you would want to be transmitting everything that you get, and you're not. If you see 000s come through, we need to know what those zeros are and how long they actually last, because some of these will be put down in very quiet environments, but they also may be later on interspersed in between, say, distributed fiber, or have many levels of them all the way to the surface. So I'm thinking transmitting nothing would make it becomes a question as to whether is there anything to transmit, or is your sensor actually working?
Yeah, that's it. There's a problem with putting these fibers, these fibers down borehole. They get so much data up, and what do you do with it? It'd be nice to know what you're just talking about, John. John Holmes, is it John? Jim. Yeah. No, it'd be nice to just get the useful data if you knew what it was.
Can I make a comment there? Because it's you mentioned distributed fiber channels, and Jim, for just so you know, on a distributed fiber channel, you don't know what it is until you get it. All right.
Right.
In other words,
if you knew beforehand, fine.
Yeah, you're interrogating that sensor from the surface, and you don't know what you're going to get until it comes back. And so there's no intelligence there. There's no anything else. You just get what you get. Now, if you've got an electronic sensor downhole, you can make some judgments. But if you're dealing with a sensor that has over 130 dB of signal to noise, trust me, that it's not quiet. You're always getting something in the bandwidth that you're looking at. And if you're dealing with a bandwidth of 0.01 or 0.05 hertz up to, say, even 1,000 hertz, you're dealing with signals that with that much dynamic range, you're picking up things like tidal motions and noise from miles and miles away, and who knows what. And those sensors at that point are so sensitive that you can put it in a large room, and you can go to a corner, put the sensor in one corner and go to the opposite corner and whisper, and it'll pick it up. So it's from that standpoint, you're never zero. But on the other side, like you said, transmitting data is a problem. And one of the biggest problems that we have downhole is how do we get all this information from down there up? In fiber systems, you interrogate it through a fiber. And so in 3D or in 3C systems, when you have a lot of sensors down there generating a lot of this data, then you have to use fiber as well, but just for data transmission from that downhole sensor to the surface. And so, because normal electrical lines over those distances, this is not coax. And there are times where you can approximate coax, but it's not coax. And so you don't get the speeds that you would get like out of a cable TV coax. So transmission to the surface is a real issue. And so we solve that very typically by using a fiber optic system from downhole to the surface. I hope that answers your question, Jim.
Yep. And I'll add before, while you're thinking, I can see you thinking, is that when we're looking at very odd signals, what you might consider odd, we actually consider very exciting. So if we're looking at tidal signals, there are groups of scientists out there that said that we get so excited to actually record tidal signals and then want them. And the very, very, very long period to the very, very short period, very tiny, tiny little cracks going on. It depends on which scientist you talk to as to how excited they get. But there's, for your entire bandwidth, you've got a bandwidth of science that also needs to have it met.
Yeah, and they can get quite excited.
So I want to note, I want to make sure that the other participants on the call don't feel shy to participate in the conversation as well. So I just want to kind of go through and make sure everyone has a chance to introduce themselves, but also welcome folks to jump in on the conversation, as something piques their interest. So I see we also have Alexei Titov from Fervo on the call, and Fervo had some recent very exciting announcements, so welcome.
That's true. Yeah, hello everyone. My name is Alexei Titov. I'm a geophysicist with Fervo Energy, so I also affiliate with Berkeley Lab. Hello, Michelle. So I'm mostly focusing on distributed fiber optic sensing, and I'm really interested in the three-component distributed acoustic sensing enhancement. So that's something, I guess, as Fervo, we also have our senior geophysicist Sirish Dadi, who also here on the call. And I guess we are interested both in the development, just to see what there in this prize, and we might also house some testing in our wells. And my personal interest is again how we can use, for example, DAS box we have and convert it to 3C system. So if anyone has ideas how to build some mandrels and put it to high temperature environment, I'd like to discuss that. And another thing is clamping. If a fiber system, you do not have electrical line there, so how you will clamp it, that's another interest of myself. Yeah. Thank you.
So often, Alexei, your cable going down, if you're doing it on wireline, it's actually a hybrid cable. So you do have electric copper lines as well as your fiber tubes.
Yeah, that's one solution. Yep, but sometimes they're a pure optical system.
True.
So,
true. If you can figure out how to make an optical go mechanical and clamp, I'd be very interested.
It's like power over fiber, 16
Exactly.
watts by fiber.
Hey, my name is Surish Dadi. I'm the senior geophysicist at Furvo. I actually have a bunch of questions, mostly on administration side. I don't quite understand. I'm sorry, I'm kind of new to these kind of grants and prizes. I don't quite understand the difference between cash and voucher. And I'm also interested in knowing how much is the phase 1 cash voucher, phase 2 cash voucher, and then phase 3. And I'm also interested in knowing what we can do, like, can we reimburse for any services we get for these vouchers? For example, let's say we have to move this equipment from place A to B, and we have to use like mob demob services, right? Can we use those and things like that? And then I have some other questions, so maybe if you can throw some light on this.
Sure, I can answer those. So the essentially cash that teams win for these phases is simply cash with no strings attached. So whichever, usually there's a captain for the team, the person who actually submits the application, and then that cash goes into that company's or that team's bank account with no strings attached. So that's just for you and your team to work if you're a winning team on your innovation. Well, vouchers is specifically to work either with a national laboratory or a private facility. The private facility does need to be, they do have to make sure they submit essentially a form online and then approved by American-made challenges. So it can't be any private facility without doing that application process. But if you read the rules document, there's a few steps on that. So let's say you want to work with a private lab that isn't a national laboratory. As long as they submit an application or approved, you're welcome to work with them. And the way that works is, unlike the cash, those vouchers, so it's $75,000 for round 1 or phase 1, goes directly either to that national laboratory or that private facility to have national lab or private facility staff work with teams directly on their innovation. Is that clear?
No, so when we work with a private facility, and let's say we don't work with any national lab, can we still use the voucher as long as it meets the requirements?
You can work with a private facility as long as they are approved by the American-made challenges, which is the program that this prize is under. So that private facility would need to essentially send in a form, which is you can find under the resources tab. And if they are approved by American-made challenges, then yes, you're welcome to work with them.
But if we ourselves, if we ourselves private facility, because we can test equipment in our wells, can we use this voucher for ourselves? If we approve private facility?
That's a good question. I have not got that question before.
Well,
I do not know. Let me follow up on it. I don't think so. I don't think it would work that way, but I can make sure, because yeah, let me check on that and I can get back to you.
Yeah, so on that question, another thing I want to know is, like, on phase 3 testing, like where are we testing? What are the conditions where we are testing? What is the depth? I mean, we need details on all of that, if possible.
That's
like
a great question.
How big is the well? How deep is the well? What is the pressure? What is the temperature? How long?
Yes, I don't have information on phase 3 yet and where our testing facilities would be. Michelle or Ernie, I don't know, or Zach, if you have an idea on that.
We have ideas.
We do.
One of your fertile wells.
Well, that would be fantastic.
Yeah.
And you can use a voucher for Schlumberger to come and put the instruments in the hole. I don't know if you can do that. But we have several candidate geothermal wells, but we also have high temperature facilities at the laboratory, that we can put them in ovens and run them for a couple of months and just see how they perform, you know. And so it's going to depend on what you hand over to us for testing. You know, it has to,
yeah, I do understand
fit
your
in
question.
a well.
Yeah.
Yeah.
There's specifications in one of the tables that says it has to at least fit within this volume, right? But then you're asking, well, you need more details because there's a lot of room in that volume as to whether you really need to do.
Yeah.
So we've had this discussion with Zach as far as that goes, and there are other geothermal operators that are also volunteering to say if you want to put it in a real well, you know, they're available to speak to. I think this is still a work in progress, Zach, as to actual positions where we would go.
Yeah, I mean, my comment is coming from practical experience. We know these tools which were tested in lab in ideal conditions. They did really well. We got them into field. Boom, they don't work.
It always works in the lab.
I've never heard of that happening before.
So I mean, I think that would be ideal to actually use a real well. If it is for a well, great. We can make that happen. We need to. Well, I say that, but if I go talk to our drillers and completion engineers, they would be like, "What the heck are you talking about?" So, but that's an option we would be very interested in. And another thing I am looking at is like there is a timeline for judging and few other things. If like for phase 2, like what are the exact requirements? Is that all already specified? What is the testing for actual testing for phase 2 going to be like? I also have let's say a couple of partners. I want to know, like, if I work with one company, should I be only working with that company, or can I work with 2 companies?
Suppose there's just 2 companies who are collaborating, or 2 or 3 companies who are collaborating on this prize money. Can they both get a prize? Say one is one aspect, you know. Suppose Harold comes in and says, "Hey, I got this neat module with this accelerometer, and so can I get all the money from prize A?" And this other company comes in and says, "Oh, I have this great way to get data up to the surface, you know, and process." Can they get another prize, or do they all have to be on the same prize award?
Sorry, I'm unclear on that, on your question exactly, Ernie.
Well, I can maybe, but let's say I want to work with Harold and also James, or the person who talked about earlier. I want to work with both of them, let's say. I will be like a collaborator and working with them. So I'll be in Harold's team, and I'm also going to be in James' team. Can I do that?
That's a great question. I believe that you can, as long as you have obviously 2 different innovations or prototypes that you're working on and 2 different team captains. But let me also make sure that's correct. I can, if you drop your email in the chat, I can follow up on both your questions about private facilities as well as that.
I would also just say, for one of the things I think I'm hearing in this question is the scenario where it sort of depends on who advances to the next stage of the competition and different teaming configurations could arise. And Lisa, correct me if I'm wrong, but I think there's enough flexibility in this prize that you kind of want to see the best innovations come to light without being overly prescriptive about how we get there.
I got
right. Like, yes. I don't see like a lot of structure around how phase 2 and 3 will be carried out just yet, because it partly depends on what comes out of phase 1.
Yes, Lynn, that's a very good point. So, that's partially why we have kind of open-ended answers to some of these questions, because it makes a big difference what innovations end up coming through and then which teams end up moving forward in that process for phase 2 and phase 3 to answer some of these questions. But
one of the things we've seen from other prize competitions is there are always subsequent opportunities for teaming beyond the initial application stage, you know, and part of the goals of these prizes is often to attract other industry and investor participants into the prizes as the technologies advance. So I would say, if you've got an idea, put in an application and then let's take it from there. You know, you're not, when you put in the application, you're not signing a contract that says, I'm never gonna add other team members or, you know, so I think there's a bit of flexibility. And one other thing I would say to your earlier question, Sarif, was that when you talked about in like downhole testing, I mean, obviously Fervo has quite a lot of wells that would be suitable for that. I will also just offer to others on this call that are looking for that. I don't think we have anyone represented from Calpine today, but they have also just offered that they're very interested in making their wells available for testing. So that's something that, you know, we can connect you to them if there's folks that are looking for those kinds of partnerships.
Doug, you're still here. Would Forge be a possible site for testing?
Yeah, sure. In fact, there's wells there that are dedicated for the purpose of testing equipment. And Forge is in the right temperature range.
I want to make sure we get to everyone and answer their questions. So we're happy to stay on a little bit beyond the line. Doug, since you just unmuted, do you want to introduce yourself really quickly?
Yeah, I'm Doug Blankenship. I'm actually a detailee from Sandia National Labs to DOE. I'm supporting Zach and
okay, great.
This initiative. Yeah.
Great. Awesome. Okay, so I think we've got a couple more folks. So I want to make sure we have a chance to introduce. So it looks like Ecor Joshua. I don't know if I've reversed your order of your name, but you are looking for a team to join. Sounds like you're a student. So maybe you want to just quickly introduce yourself. And I liked your comment about the Earth's core, which, as I understand, is changing. The state of matter that we know as the core has changed, which is mind-blowing information. I saw you drop that in the chat. But want to briefly introduce yourself?
Yes, yeah. Thank you. Good evening from Nigeria. My name is Icho Joshua. I am a final year geoscientist student from University of Jos, Nigeria, and I have experience in embedded system and advanced sensor development, and particularly seismology. I have worked in exploration works, and I have experience in modeling, in hydrogeology and seismology. I've worked with IRIS seismic analysis tools, and I've also been trained by Aquanti Canada in hydrogeological modeling. So particularly, I'm interested in leveraging my embedded system skills and IoT and hardware programming to develop systems that will be used for monitoring, especially in this geothermal competition and well monitoring. So I'm looking forward to joining the team. If anybody has an opening for me, actually the competition was recommended to me by a friend who is based in the US who saw it on Herox. So I'm relatively new on the platform. I've tried to actually send some joining requests on Herox, but I don't know if the join button is actually working. So that's
Got it. Great. Well, maybe you can drop your information in the chat for those that are looking to add to their staff. It sounds like you'll be graduating soon. So glad for you introducing yourself. All right.
Thank you so much.
Thank you. And then we also have Rob McDonald from GE on here. Do you want to introduce yourself and let us know what questions you may have?
Hi, everybody. Yeah, I'm Rob McDonald in General Electric. I've worked, I'm a MEMS engineer. I've worked in accelerometers quite a bit, developed a downhole Excel for elevation finding, high temp Excel for elevation. And my group here, one of the things we're working on is high temp gyro for azimuth finding downholes. So we did a study on that. And we have data and a paper with 300C gyroscope for azimuth finding. So that technology has, when we developed that, it has a high temp MEMS technology that we developed and built here in New York in our foundry that we call Polaris. And we also have high temp ASIC, which we're doing out of one of the high temp CMOS foundries. So we have those two technologies. If you guys can hear me and see me okay? There's what it would look like in chip scale. So that's not really a solution, but I wanted to put it out there and make it available. We haven't done seismic sensing, but we're really interested to know if our technology could be applied to the seismic world. We have some pretty good results at these temperatures. At least this much of the technology seems to last indefinitely at high temperatures. Our MEMS process is a high vacuum MEMS process, so it's all silicon, high vacuum, and there's like if you're doing resonators inside cavities, we essentially have no Q degradation that some other technologies have. So we would be interested in partnering with someone who knows MEMS for seismic sensing, which is not our area, but if someone was interested in our tech, we would be happy to talk to them about it and see if we could be useful. I also don't think, given the scope of the prize, we have experienced downhole. Baker Hughes is part of GE, so that's kind of in our DNA. And I know some of the folks by name on the call today, but that's probably not really in scope for what we have going here today at the center, but we could probably provide something like this, or something could go into a bigger hybrid. And our MEMS process, it's ours. We have the foundry, so we actually have a pretty quick turn time on it. So from the sense element point of view and the ASIC point of view, we actually could probably turn within the budget new sensors if that was interesting to someone, as long as they had the packaging part of it and they could scope the testing part of it. Yeah, so that's kind of what I wanted to put out there. And I guess, I don't know where I would put that, if that goes on the Hero thing, or happy to put that out there somewhere.
I think post something in the HeroX offering that capability, but also use our teaming form. And if you can't, because I will note that some of the larger companies have mentioned they can't always, fill out a teaming form without all sorts of permissions. If that's an issue, just email us. But we are taking some notes. But feel free to email us, and then this just goes to everyone. If there's for some reason you cannot put something on the form, or you cannot put something in the teaming form, but you want to make that offer, let us know, and then we can try to match you up with those who are expressing those kinds of needs, or sort of generically express that there are some companies out there that have these kinds of capabilities. So that's really helpful.
All right.
A quick question.
Thank you.
On the ASIC, Rob, what capabilities do you have on that? We are familiar with MEMS. This is a high vacuum MEMS accelerometer that's also made for those temperatures. And so we do that here as well. But I'm interested in your ASIC because we're just in the beginning stages of using a 3D printer actually to start making silicon germanium high temperature electronics for a similar process to the standard fabrication done, for example, on the Texas Instruments high temperature electronics, for example. But I'm interested in knowing more about your ASIC at this point and what's on it.
Yeah, we'd be happy to talk to you about that in detail. But I mean, as you know, there are a bunch of high temp ASIC foundries now that let you hit those temperatures. It's SOI technology, which you're probably familiar with. So we have ASIC designers who've worked in that space for some sensors, and they're familiar with, that sort of black art of high temp ASIC design in those processes.
I'm familiar with that. Honeywell hired me to help start up their high temperature SOI CMOS on SOI.
Yeah.
I'm very familiar with that.
Yeah, no, I'd love to, we should talk offline. I'd love to hear about your 3D printing technology too and stuff. So yeah, so that's essentially what we applied. We did a standard, foundry run on the ASIC side, and it went in, has been going into our high temp azimuth finding work we've been doing. It's not, it's you can fit a lot on a chip, right? So, but on the analog front end, it's not, it's just nothing other than like, TIAs and so forth. But of course, there's the art of the ASIC designer, right?
Yeah.
And then of course, like, so sense element in-house here with our process, ASIC from a foundry, and then hybriding them together, the usual kind of stuff. And then, there's all the arts of packaging, that we have high temp test capability. Again, it's sort of in our DNA at GE because of industrial and all that stuff. We have a lot of test systems. So yeah, we'd love to talk to you about it more. That'd be super interesting.
Offline.
Yeah, absolutely.
Great. Well, I'm excited to see some of these potential collaborations coming together on this call. And, just to reiterate, if anyone's looking for those connections, feel free to use us as a resource. And please exchange information with each other now, or if you want to follow up with anyone on this call, including, some of the Enroller or LOBNL staff for questions, let us know. And then last but certainly not least, we also have Wei and then finally Ingrid on the call as well. I wanted to see if either of you want to introduce yourself and ask any questions you may have.
No, I don't have. I just come here to see if there any new information. I learned a lot from the GE person. They are semiconductor pioneer, and they can do a semiconductor chip above 300 degrees C. So it's very good to know that.
Great. And Wei, do you want to, I know we've met you on our previous event, but do you want to just introduce yourself to anyone who's not met you before?
My firm is mainly on the semiconductor heat transfer to cooling down the semiconductor chip. But if you already have some semiconductor can bear 300 degrees C, then there's no need for cooling.
Okay, great. Well, thank you for joining us again today. And then finally, Ingrid, do you want to introduce yourself and let us know what you're looking for and any questions you may have?
Sure. Yeah, thank you. So my name is Ingrid Tomac, and I'm assistant professor in geomechanics at University of California, San Diego, in structural engineering department. So I am working what would be interesting here with modeling. And specifically, I'm interested in modeling of coupled processes, geomechanics. So that is directly related to EGS and CO2 sequestration topics. What I do are coupled hydrothermal mechanical, micromechanical models, where I can model fluid and heat flow and transport, which is coupled with mechanics in discrete element method. We also looked at some multi-phase flow and transport with CO2 and water for EGS. And then these models are also able to propagate stress waves. Basically, this is how DEM works. So there is one paper also that my previous student published where, and other people also can show this, that some sensors can be directly modeled in DEM, and then the rock can be modeled around it, and we can see how the stress waves propagate and are basically sensed in these models. So DEM models are small scale, and they are good for that type of like a borehole and around borehole scale rock. So not really for the large scale whole reservoir. what else can I say? Yeah, so basically I'm here on the modeling side, and I would be interested if somebody wants to team up with me in this call, right? My PhD was on enhanced geothermal systems and modeling. And these days I still continue looking at rock fracturing, fracture propagation of the couple processes, and also the particle fluid interactions, which are maybe not directly related. So that's all, more or less.
Quick question on some of your modeling, and given the dynamic range that we're looking at in these sensors, obviously, we're going to start picking up some of the tube waves and some of the other reflections that are occurring in the wellbore, plus reflections from in the formation from different directions, and also some of the acoustic emissions even after the frac. We're going to be picking up acoustic emissions from those fractures as they continue to propagate, or after it starts, the fracture starts closing and compressing down. So are you modeling those as well?
It is possible. So I have tested the DEM during my PhD to see if the same model, the particles are connected on contacts in DEM, and then basically the wave propagates from one particle, which is spatial discretization, to another one in DEM, as you would play the pool, the billiard. So one ball kicks another. And given if you have a small enough model and a small enough time step, so that these waves don't jump over these spatial discretization, then we can model the waves. So in terms of dynamics, I have tested across the strain rates, and in fact, like if you load rock with a quasi-static low strain rate, then we have a fracture propagation. If we do a high strain rate, then you get a shattering, like what explosion would do. So the same DM model with particles and contacts was producing all across ranges. And the other thing is that we can set the boundary conditions somewhere, around and on with the contact, and we can model different materials as well. And then also some, the different levels of heterogeneity of rock itself. And then you can maybe have a steel or whatever you have on the contact between rock and the sensor. That's not a problem. I am confident that DM is well suited for these problems that you mentioned here. Can see the velocities of particles and how these waves propagate and reflect. And sometimes also in the model, we have a problem because of the boundary and the reflection. So you get like a lot of fracturing in the corner, and then the viewers are like, that's not good. I said, maybe it is good actually. I mean, maybe this is what happens like in the lab. It's a dynamic time stepping model. Just the time step is like 10 to minus 9 seconds. It depends on the particle size and the wave propagation speed through that material.
Very good.
Okay.
Great. Well, thank you so much. And, hopefully you can identify some teaming opportunities through our forum and through this event as well. I think we have gone through everyone who's on the call, and I know that some of you, we've gone over the hour, and those who need to jump, obviously feel free to do so. But just want to pause there and see if there are any other questions, or if anyone else wants to stay on for a few minutes to chat with prospective teaming partners, or if we should adjourn. Okay, well, I want to just thank everybody who's taken the time to join us today. Thank you for your interest in the Geothermal Geophone Prize. A huge thanks to Lisa at NREL and Michelle and Ernie at LBNL for joining us yet again to share your expertise on the prize, as well as on the geophone sensing with the team. I hope that we see some exciting applications from everyone on this line, and definitely feel free to use our teaming forum, the HeroX platform, or just reach out to us if you're looking for some pieces of the puzzle. And once again, feel free to use our office hours or just reach out to our team for any assistance. So thank you all so much for joining us, and look forward to seeing what kinds of concepts that you come up with.